Welcome, everyone. We're so excited that you're here because we've got a really great panel. Boy, I had to really just pull back the reins just to get this thing started because we're ready to go. So our topic is the future of cloud testing, because we're talking about software testing in this era of cloud native, all the technologies that we get to work with today and creating software in. My name is Mitch Ashley. I'll be your host and panel moderator. Hopefully, we'll see how it goes with this group. It'll be a lot of fun. We have some really great experts, and I'll introduce them in just a moment. Want to especially call out and mention our sponsor, Tricentis, who is sponsoring this series, the DevOps Roundtable. And we also have episodes that appear twice a month on techstrong.tv, so you can check those out and watch other great conversations like this one that are pre-recorded. But we're live and in person and ready to get rocking and rolling. I do want to point a couple housekeeping items. Our webinar software that we're using today is really interactive. We'll bring down this image in a moment. You'll see everybody that's on the panel. But on your right-hand side, there is a chat, part of the application, as well as a Q&A. And if you'll use that, we are going to engage with you both through our conversation and also in the chat. So ask your questions on Q&A, bring up something or respond to something in the chat. We're happy to engage with you and interact with you that way. We really strongly encourage it. Also, we're recording the webinar, the roundtable today, and we will send everybody who is attending, we'll send them an email with a link to that recording. And guess what? No slides. You don't have to worry about slides. You don't get slides. We're also giving away 4 gift cards, Amazon gift cards at the end of the roundtable. So stick around. We've got an hour to land this plane and hit the runway, 3-point landing, which we will do in just about 56-7 minutes or so. Well, let's move on to our topic, the future of cloud testing. I have the extreme pleasure of introducing our panel today. I bring down our slides. There we go. Great. Let me begin by introducing, or have you introduce yourself, Rosalind Radcliffe. If you would just give us a brief intro and tell us who you work for.
Hi, I'm Rosalind Radcliffe, IBM Distinguished Engineer responsible for DevOps for Enterprise Systems. So I'm responsible for making ZOS DevOpsable, or bringing ZOS into the cloud native development environment, including modern testing practices, cultural change, bringing that new way of working to ZOS as well as working with clients and their DevOps transformation. So our largest industry clients, helping them understand how they can improve their processes.
Fantastic. And passionate about software quality, I know for sure. It's a big topic for you. Let's have Eran introduce yourself. Tell us a little bit about you.
Of course, thank you. Thank you for having me. My name is Alan Shimel. I'm a senior director at Perforce in software testing for over 21 years now, and author of 3 books on continuous testing in DevOps. I work with Perfecto, which is a cloud testing solution. So I hope to share some of what's happening in the market today and why cloud testing is emerging these days and in the future. So again, excited to be here with everyone.
Fantastic. Next, how about Donald Lutz, if you'd introduce yourself.
Hi, my name's Donald Lutz. I'm the lead Azure architect at Greenbrier Companies, where we're moving from a legacy data center into the cloud, and I've spent the past 10 plus years helping company move that direction in modernization.
As you can tell, Donald is a software guy by the amount of light in the room. Likes to work in one of those dark environments.
I tried to make it brighter. I turned all the lights, and it still hasn't happened. So okay. It's better.
Great. Welcome, Donald. James Bach, if you'd introduce yourself too.
I started testing 34 years ago. As of a couple weeks ago at Apple Computer, I now work for Tricentis part-time and part-time running my own company, teaching rapid software testing, which is the test methodology I developed. I spent the 90s telling every old guy in testing that they were wrong about testing. And I also popularized exploratory testing. If you've ever heard the term exploratory testing, you heard it from someone who heard it from someone who heard it from someone who heard it from me. And so now the whole world doesn't understand what exploratory testing is because of me. And I try to apply social science to software testing and have a humanistic systems thinking approach to it that is anti-authoritarian. So hopefully there's lots of prickly things about that will pique your interest.
You have words, lots of good words. So we're
I have all the words.
Look forward to that. So you're the Kevin Bacon of testing. Is that where seven degrees from James Bach?
I do know a lot of people. That is true.
Okay. Okay, good. Well, we may find some of those connections. So let's start our conversation. There's so many dimensions we could talk about testing and software quality. And the title of this is The Future of Cloud Testing. I think it's really the future of testing, because even when we say cloud, rarely is an application just in one environment, right? It might operate in the cloud. It might operate in a hybrid, may talk to on-premise, may talk to third-party services, SaaS, database, all kinds of stuff. May have a mobile app that goes with the web app. I mean, the complexity of what we're dealing with in applications that, the business almost views as a check this button and I get a mobile app, and I assume it'll be tested. Check this button and I assume I get this API to the software. We know it's not that simple, but that complexity is, not getting smaller. It just gets bigger and bigger. And we're working from the newest software to software that's been running in our businesses maybe for quite a few years. Rosalind, why don't you start us out? Talk about how you see the spectrum of software quality and testing and dealing with some of the complexities of that.
Yeah, I think it is important to recognize that software is everywhere. I mean, it's in everything we do, and it is becoming more and more critical in the world. For years, for the last 30, 40, whatever, banks have used computers and financial transactions and insurance companies, but cars and everything else, we all have to pay attention to software quality. Software quality is something everybody is responsible for. And with this highly interconnected mess, is probably the best way of putting it, most organizations end up with, we need to make sure we are applying quality practices across the process. And that's testing is important, testing early, doing unit testing. I know I'm going to cause an argument, so I'm going to start it now. Everybody's a tester, though each person's a different kind of tester. Developers can't get away with just writing code. They have to test their own code as well. They have to show that what they wrote did what they said. But then you have to have other kinds of testers. You have to have this wide variety, but you also have to have the right automation in place. So there's no manual process where you don't need one. Those repeatable things need to be removed. We need to take advantage of the cloud and its ability to dynamically provision, run tests, and throw away to get our consistent testing. Whether or not I'm testing a COBOL application that runs on ZOS, or I'm doing my mobile front end, this repeatable testing, this making sure I have a good code base, making sure I can repeatably test, use the right test data, which is I think the hardest problem, making sure I have the right test data to test, to do my automated testing, all of this complexity. But, we have to pay attention to it. It's a critical piece of this process, and making sure we're considering quality from the very beginning of the idea, what do I need to do, all the way through the environment, and helping everyone understand their role in quality.
Well, a lot there for the panel to react to.
I'll start there.
Okay, I have some concerns about what you just said. When you say repeatable, can you help me understand? So I'm finding I want to ask you a question, actually. I'll be the first. Can you help me understand what is it that we're repeating exactly?
So there are things that are highly repeatable in the process, like deployment. When I deploy a piece of software, that is a very repeatable process, therefore should be automated. If I'm making a database change, I can automate that process. I don't need a DBA to go in and make the change. That can be an automated process.
But that's not testing.
No, but everywhere that I can automate, I should automate so that people can use their brains to do the things that we need them for, the non-repeatable tasks.
But aren't they going to use their brains to maintain the automation?
Yeah, they're going to use their brains to maintain the automation.
Which is going to take all their time.
No, we have it, depending on the automation, you don't want to go to extremes, but there is no reason why I can't automate a deployment process. There's no reason I should be doing manual steps as part of a deployment process.
But I'm talking about testing, not automating a deployment process. Automating a deployment process is not testing it.
But it is, well, actually, if I do it repeatedly, I am actually testing that the deployment process is working. And
but the automation is not doing the testing. The humans do the testing.
So yes, I think there are lots of parts of testing. And I think my point is it's not just testing that delivers software quality. It is the entire process. It is the entire process from idea through delivery that is going to determine the quality of what you're delivering to the end consumer. And there are lots of pieces of that. And I think it's important to recognize that there are lots of pieces and parts to this process, and automate the parts we can that make sense. Focus on making sure I can get automated testing where I can do automated testing, where it makes sense. Making sure the developers are testing their first things and going through the process and figuring out the right ways to understand chaos testing, throwing in errors. There are all sorts of things that you're going to want to do as part of this process. A lot of that chaos can be automated. I can automate killing things. I can do all sorts of things. What is it that I want to automate that I should automate? What is it that is a human going to look at and pay attention to?
That's a great topic around testing. Go ahead. I'm really curious to hear automation, because that's sort of, sometimes managers can get too enthralled with, let's just automate everything.
Well, I think there's no such thing as automated testing. I refuse to use the term. I used it for 15 years, and then I realized I was saying something toxic that was causing my clients to misunderstand what testing is. Notice that no one ever asks a programmer, are you an automated programmer or a manual programmer? And if you did ask them that, they would laugh, right? Why is it? Ask yourself, why does that seem like an absurd question? I think the answer is everyone knows that programmers work with their minds. And you don't automate that. If you use automation as a programmer, you simply elevate yourself as a programmer. You simply sit on, you're called a high-level programmer when you automate things as a programmer. And yet when people talk about automated tester versus manual tester, that doesn't seem absurd. And I think that's because most people think testing is pushing buttons. And my whole career is dedicated to knocking down the idea that what testing is pushing buttons. We don't push buttons. We critique, we analyze, we model. And I know I sound like I'm arguing with you, Rosalind. I don't think I actually am. What I was trying to get you to do was, I was trying to get you to clarify how you saw the difference between people and machines. And I'd really like us to be as clear as we can on that, because otherwise, what I'm worried about is management hears what you say and they go, oh, thank you, Rosalind. Let's fire all the testers and have AI do it. Thank you, because RPA, you know, I just found out what that means. Robotic process automation. It's a big thing, apparently. The rest of the world has now discovered automation that has been dogging testing for all this time.
Well, let's do this. We keep talking about the developer. I want to hear what Donald has to say from a developer perspective.
Well, I kind of agree with the deployment automated testing part, just because I've been doing so much cloud native over the past many years that, I was at a company where we built multi-cloud storage, so the goal is to have Terraform where you can automate all those environments, because you're trying to deploy in all those environments and they're immutable when you deploy them. So you know that when you make the change, it'll be tracked, because I'm concerned with, I want to be able to, the chaos engineering thing, I want to make sure my infrastructure is working. So if I do unplug Kubernetes, we could run a test and it could be that they think the API is failing, but it's really that the cluster's not up. And there was an example last weekend when we had an issue where we had too many connections that happened relative to our Postgres instance, and it really caused Kubernetes to fail, but it looked like related to one of our data processes, something else happened. So, there is a level of, when you start getting to that chaos concept, you have to involve everything from databases to what kind of automated tests do we have? Do we know what the infrastructure is doing? Are we sure everything is up? It's all those Deutsch problems, the network is infinite and there's one admin and all those fallacies that exist. So because I've been doing so much cloud native, my view begins that testing has to encompass so many things, and you do have to use your brain. It's not like you don't use your brain. It's just that there are some tools that assist you and that help you get there. For me, it's the whole stack. I can't be guaranteed, because I'm relying on parts like Kubernetes that have their own issues and they change between versions and all the things that start happening. So it's sort of like, how do we functionally define all those things?
Donald, do you see that people are saying don't use tools? Is there anyone saying, hey, stop using tools? Because it kind of sounds like you're
I'm not saying.
Sorry, go ahead.
No, I'm not saying not use tools. I just mean that, the problem is when you start getting the level of complexity with all these things, that the ability to do manual testing gets very complicated.
There's no such thing as manual testing, unless you mean test with my brain. I'm testing with my brain all the time, even when I use tools. And by the way, I started as a programmer. I worked in 2 successive teams doing development tools. I was on the Borland C++ project and the C++ project at Apple Computer. So I come from a developer and developer tools background. And I don't understand when people say manual testing, like, what do you mean? Do you mean I'm using a keyboard? Programmers use keyboards too. We all use tools. Everybody uses tools. There's no controversy about using tools, is there? I mean, we don't need to make an argument that we have to use tools. We need to make an argument that we need to be responsible about using tools, right? How do we be responsible about using tools? I'd love to hear you talk about that, all of you.
If I can chime in, Mitch, I think that, being in this space, and I work with so many enterprises in the mobile and web space, and what I see, they can have the mobile application. Let's take Bank of America, for example. Okay, last week, iOS 14.6 was released. Right now, iOS 14.7 is in the 3rd beta. They can change 0 lines of code. They still need to make sure that their application, you can log in, you can deposit a check, you can transfer funds, everything front and back end works, etc., etc. They can only accomplish this end-to-end validation through automated testing. And yes, I agree with James, it's being driven by humans based on specifications and, expected versus actual. And there is a room for some manual testing as well. But I think that we are missing the point here, okay? At the end of the day, software is not done for test automation. Software is being built to serve the end users, to delight customers, to have a proper end user experience, to perform as expected across different geographies, different platforms, web, mobile, desktop, etc. So how we accomplish that can be in many ways. Can be with RPA, can be with test automation, can be with some manual testing driven by humans based on strategy. So I think that's the conversation which needs to happen.
Well, the audience is definitely favoring it's okay to use the automated testing term. So I guess
they have no idea what that means, audience. You don't know what you're talking about. You haven't thought about it.
We're going to send James to the
to
automated testing 12-step recovery program, see if we can help him. We're not going to change his opinion about it.
So I think
I work with this stuff all the time.
I know you do. I'm
sorry, Rosalind.
Yeah, so I was just going to say, I think we need to be careful. There are humans involved in this process. The idea of automated testing, and I'm gonna keep a really simple definition to help us maybe not focus on words that cause problems, because I don't know that we're actually all in disagreement. We might be in violent agreement instead. It's just the words that are causing problems. If we think about automated testing, I have someone who's good at testing build some set of automation to allow them to do a series of things to validate that capability works as expected.
That's
they're gonna write
impossible to do.
They're going to write some automation, and there is some level that they can write some percentage of automated tests to reduce the risk. And then there is some amount of other testing that's going to go on in the environment. But there are a set of things I can validate. I can validate that an API responds as expected.
No, you can't. You cannot do that. That is literally impossible to do. What you can do is validate that an API responded as expected in some limited sense at some time. But what you can't do is validate that it will continue to respond as expected, which is the only thing we care about validating, is actually, will it continue to work? Will it work? It's the question that we care about as testers. And we can never automate the question, will it work? We can only do little output checks at little moments in time. So that's a really important thing for testers to understand. And these aren't just words. These are fundamental concepts of what is possible, what is computable, what is not computable, what it means to do a check. I come across testers all the time who say, my job is to prove the product works. You can't prove the product works. You can't ensure that it works. That is completely outside the philosophical limits of testing entirely. And unless we understand that, we won't understand the limitations of this automation that I agree is helpful, but we need to know what it's helpful for and what it's not helpful for.
Okay, so I would like to put a pause on this. Our audience is with us, but they want us to get back to cloud testing and the testing in that environment. What are the challenges with that? So, Aaron, I'd like you to kind of help us get back to what do you see the scope of what's involved in, because that environment has opened up to so much for us, so many new avenues of what we have to consider when we think about software quality and testing.
So I think when you talk about cloud testing, you talk about few things. You're talking about parallel testing, how many things you can actually cover in a single environment as a service, if you like. You're talking about fast feedback. You're talking also about cost. Okay, there are a few things here. And I will unfold all of these because, again, taking it to my backyard, which is the mobile and web. Okay, think about any responsive web that you have today. Maybe it's the DevOps.com website or whatever. You need to make sure that anyone can access this live session on any mobile device and on any desktop browser, on any operating system. Okay, you have 5 testers sitting in a different geography, organization, or it can be a service provider, doesn't matter. How do you give them the access to all of these different platforms and configurations that are changing every month? Okay, without really nagging the IT guys every day. Okay, that's one way or one benefit of a cloud that helps developers, by the way, and testers. Again, I won't go back to this discussion who is doing testing. It's at the end of the day enabling platform as a service to each and every individual within the organization. But when you give them this access to the cloud, you're also enabling them to drive faster insights. We call it faster feedback, shift left. We have so many different terms for that. But at the end of the day, you want to acknowledge, okay, the developer has done, X amount of pull requests a day. What's the impact on these code changes across these 10 or 20 different permutations? By expediting this environment as a service in a cloud, you're allowing them to improve velocity, improve the fast feedback loop, and obviously, hopefully, drive better quality of these applications. So I think just to summarize, it introduces the cost. So it's the cost, it's the fast feedback and velocity, and productivity at the end of the day for the entire team that everyone can really access across different geographies.
Yeah, I agree with that.
Yeah, you brought up
add
environments.
something in. One of the things that happens with cloud native that a lot of companies aren't used to the whole concept of distributed computing. So once you start building distributed solutions, you have to worry about resiliency, observability, all these things, because it's not running in one particular place or one particular environment. So, that whole distributed systems concept has to be really well understood by organizations to figure out the right way to test. Because it isn't just like, oh, you're just testing one monolith, one database, in one server that you know what it's going to happen. You've got multiple databases, you have multiple protocols, gRPC, HTTP, different security protocols. So when you start thinking about distributed systems, you know, testing is a very broad definition. We won't get back to that other discussion, but because of that, you need to be able to wrap all those in, because you're really, in getting people to understand, we're now distributing, which means we need to know what happens if I can't connect to a database server. How many times do I retry it? Do I do a circuit breaker? What are the methods we're going to use to make sure we understand? Can't prove it's going to respond, but how do we mitigate that so we can get to 99.999 theoretically and get to those wonderful numbers that all businesses want, because they say, oh, we're up all the time. You know, even Netflix, the chaos engineering experts, have had their own issues with having to move things between different AWS regions, because it's just not that simple.
Making sure that we're considering all of the aspects of this, including the performance characteristics, the way it's not just failure, it's does it perform fast enough? Do I get the response fast enough if something's going on in the system? Making sure that I'm taking all of those things into consideration. We think about large scale systems, you know, my credit card authorization has to respond in how much time? I don't have a choice. So I need to make sure I'm looking at all the pieces of code that I'm developing to make sure that I'm going to meet that goal in the end. I can look at the code I write at the very beginning and look at what I'm doing to performance. And if I do something that takes a second in the very beginning, I know I'm going to fail, because I know the response time has to be less than that in the end with all of these connected piece parts. So there are a lot of aspects to this cloud world that we have to consider, because nothing's in one place anymore. Well, nothing's been in one place since, I don't know, 1960s or so. Everything's been spread. You know, as soon as we got PCs, et cetera, we started spreading the workload. How do I do this effectively and make sure I understand how all of the pieces are going to work together? And do I have a good chance? I mean, we can't guarantee anything with software. We can't say there's zero bugs ever. There's going to be something. How can we increase our reliability chances? How do we reduce risk in the system, or make sure we understand the risk of the system so we can assume we're going to work?
So if I understand all what you guys are saying, the future of testing in the cloud is super complicated. Am I getting the wrong impression? It sounds super complicated what you're talking about. You even say chaos engineering, which implies super complicated. Is that?
I would agree with you, James. I think that everything around us becomes complicated, because even if you're no longer building software that is standalone. Almost any software out there has dependencies on so many different interfaces. Some of them are, your own interfaces. Some of them are external interfaces. Think about, any web application that is out there, or any mobile application that is out there. It still depends on network connectivity. It depends on the network provider. It depends on the operating system changes. Okay, so the world around us is becoming more complicated, and I would agree with you, James, from the previous conversation, that you have limitations in how you validate your software in this very growing, complex world, because you cannot really mimic so many different interfaces that are impacting your software.
Right.
But you can definitely, obviously, try, but be smart about how you design the software, B, design it for testability, and have as close as possible testing environment close to your end users.
I think design for testability is the real challenge. That's so important. I hope you wrote about that in your book, Rosalind. Design for testability. That's a big deal, because, for instance, I was testing at eBay a few years ago. They have something like 250 different hosts that interact. There's no way I can press a button and say, give me a eBay sandbox in the cloud that I can test as a tester. So what that's done is that forces eBay testers, they test in production. Everyone's got to test in production, because you can't duplicate the Hadoop and the 1,000 servers just because you want to have your own copy of that you can do anything you want with. And I guess doesn't Netflix do that too? They do lots of stuff, not in some separate cloud sandbox, but in essentially testing in production. I don't know, but I'm from what I've read, it seems like they do. Maybe you could say more about that, Donald. But that's a real challenge. I call it squish right. People talk about shift left. What that usually means is pressure comes down on testers so that people say, well, you don't have time to test anymore, so you better shift left. You do a little bit on the left, but you can't do a lot. And everything gets squished right into production.
To some extent, I have to say, I really, really, really hope that the financial institutions are not testing their algorithms for the first time in production. I really hope my bank account balance stays correct. So we got to be careful when we say testing in production. There are things I can validate my algorithm works. I can validate my math works. I can validate certain things before I ever get into. And you can, depending on the environment, recreate the environment. I know plenty of organizations that do some level of almost full recreation in order to do enough testing before they get into production so they can meet the regulatory requirements of financial institutions, et cetera. So there are some differences depending on the kind of transaction you're dealing with. Absolutely. There are certain transactions, there's certain kinds of functions that you really got to make sure that they're going to work before you're going to go.
Well, you hope, but I mean, when I was consulting at LiquidNet in New York City 10 years ago, one of the interesting problems they had is they have to test based on stock market information, right? Well, they cannot simulate that except in tiny little ways. What they had to do is they have to test with live stock market information every day. And I said, why don't you record it? They say there's way too much. It's impossible to record it. It's too much data. So we just have to use fresh data every day, which limits the testability of their systems. But they basically explained to me it's a major engineering project to simulate this stuff in really interesting ways. And so there's lots of challenges there.
There are lots of challenges. That's why you focus on the things you can, the smaller things you can do as an early test versus the things that are harder to do that you need more data for. But understanding the difference between what kind of testing you're doing and whether or not you're testing at the scale or the variability versus testing at the algorithm, the error checking, the whatever. The kinds of testing I'm doing matters as well as to where I'm going to do it. I better check for an error. Yeah, you do what you do. I can check for errors. I can check if my database connection does not work, does my application handle it in development? I don't need a large scale environment. So we need to look at making sure I'm doing the right testing at the right phase and accept the risk profile of the code. There is no perfect code. I mean, as you've said, there's no way we're going to write perfect code. We're humans, we're people, we write code. And you made a statement about AI doing testing. You know how often I hear the AI is going to replace developers? Yeah, that happens too. It's not going to happen either. We can't do that. It's taking the human brain to do these activities. Absolutely. Let's make sure we're doing the things in the right place in this spectrum of testing or of validation or whatever the right words we want to use are.
Do you have a hopeful attitude, Rosalind? Is that how you see it? Are you positive about this?
Yeah, of course. You've got to be positive. You've got to be
so I'm the opposite. I'm the opposite. I'm the exact inverse, I guess. Together we make one being.
Yeah. So I'm not.
What I wanted to say is this topic around testing in production, it comes up fairly often. And I would just add to the conversation, I think there are some well-defined testing in production. So things like canary testing for some, controlled load testing. Donald, you mentioned chaos engineering. That's about resiliency.
Blue-green deployment, so you can drop back too.
Yep.
And I think and then James, you talked about there's, and Rosalind, there are environments you just can't replicate, period. You can only see it in a production environment. I think the other thing, I'll throw this out to the team here, is that sort of the environment is changing out from under us as well. You know, if you think of the whole infrastructure as code, infrastructure as software, you know, it's not like we know we're on this piece of hardware with this software stack that we have back in our well-controlled data center. It's talking to apps through APIs that are changing. They're releasing on their release schedule. We don't know what's happening. I mean, we're in an environment that's fluid, not a solid. Let me throw that out there. React to that.
Yeah, it's very fluid. Like, simple example, like, you know, like Azure changes its machine sizes for something you're using that maybe relates to a Kubernetes cluster, and all of a sudden you have some stuff running there, and then they've changed the way the memory is allocated on that VM. So you have some interesting things that could happen in that process because, you know, or you have to decide, oh, I'll use this version of Kubernetes. I don't want to use this version because there's some gotchas that could get me. The level of detail that you have to follow on lots of things all the time is much larger than ever. That's kind of the thing. And the reason the testing has to be across the board is because there's so many things that are involved. It overwhelms developers, testers, architects, CTOs, you name the title. There's so many responsibilities that it causes lots of issues. And it's not so simple to the business because they're like, well, I really wanted this to happen on May 15th, and we don't understand why all these things happen. So you have to sort of, which means then you have to have a very good communication dialogue with everyone involved in the business. So you can say, this won't actually happen. We need to move it to this date. And these are the reasons why, you know, and that all involves brains and thinking. And you have to really be able to state that. It also involves communication. The real thing is, as we get to cloud native, the level of communication that technical people need to do is much higher. Eric Evans, who wrote Domain-Driven Design, said it's the technologist issue to get the business to understand the issues because they are never going to come to us and ask us. They don't care. We need to be able to explain to them why things are happening. If we can't do that, then our value is probably better to be AI than being engineers.
AI stands for automated irresponsibility. And if you accept that definition, suddenly lots of it makes sense that didn't make sense before.
Well, we're here to offend not just small groups of people, but entire industries of that word. No, I'm just teasing.
Because if you think about it, what they keep doing with AI is someone uses AI to create essentially the equivalent of a child who can sometimes do something. Oh, good. You made a picture. And then they say, now you're the CEO of the company, child. You can kind of solve this pattern recognition task. Now everyone works for you from now on. And that's what scares me about this. There's lots of test tools out there. I'm surprised we haven't talked more about AI in testing, just a little bit. But there's a lot of test tools out there that are being sold as, look, oh, now your job is done as a tester. That literal quote is in one of the demo videos that I saw yesterday. And my question is, but what does the AI do? And the answer seems to be, well, it seems to be doing something. Isn't that enough for you? I'm like, no, it's not enough that something seems to be happening. I need to understand it. That's what responsible. If there's one tagline that I could use for myself here, I'm just trying to stand up for what does it mean to be responsible? Let's do automation. Let's do it responsibly. That means a human has to be in charge. That means we need to know why we're automating, what we're automating, and what the limits of the automation are so that we don't fall into certain traps. Like, I tested it. What do you mean you tested it? I mean, I ran this automation and I saw green on the screen. So therefore it's tested, right? Oh my God, no, that's not what that means.
Well, let's talk about that. AI is coming up in every product category, right? And it's used as much of a buzzword as, it may be a case statement. It may actually be some form of machine learning. You never know till you look under the covers.
My company sells AI stuff.
I think the lazy answer is it's there to replace people, because in most cases that's not really true. My question to the panel is, What is a good application of AI within the realm of testing? Are there good places where we can use AI or machine learning to our benefit, excluding the topic of we're not trying to replace people? That's not the purpose.
So Mitch, if I can jump in, because my latest book talks just about the about AI in DevOps, not just in testing, and I'm very clear about AI not replacing humans. We need to understand that this is just another technology like any other software that is here to solve a specific problem. Okay, take it to the testing space. Okay, I have so many broken test validations because my object locators keep changing because I use React Native as my development framework. Okay, that's a definition of a problem. Okay, I'm not replacing the human behind the testing, but I'm allowing the tester, okay, the one behind this validation, to cope with these ever-changing element locators on the screen. It doesn't do the job for him, okay? It just kind of keeps the test that he created running as part of CI or as part of his continuous test automation, okay? So I think that once we understand that AI solves specific problems, okay, each algorithm would solve a specific problem, we then divert from talking about, yes, AI is taking my job, because that's kind of a waste of time and a waste of conversation to have. AI is it's growing to solve and be a tool like any other software tool out there, used by human and not replacing them. So that's my statement.
If I look at the areas that I see people experimenting with AI in testing that I think I see value, they also go in the area of test data, helping me understand how to generate or how to fabricate or how to understand what is the data I should be testing early in my environment or in mid-tier, whatever. What kind of data should I be using in my environment? What's the variability to the data in my existing environment to help me understand what I should test against so I can do my early testing to try and get some understanding in that space. I see whether or not that's actually AI or not is, I'm not going to go down that conversation, but the term AI is used in that space as to, and it's probably machine learning actually, but understanding and getting the right test data, because test data is a big problem. One of the reasons why we can't test everything is because we don't have infinite variability. We don't have forever. We're not going to spend the world. So that's one area that I think is probably very important in understanding. And I know there are other areas that people are looking at AI in and understanding what I should test. So if I make a change, what other areas should I test that might be impacted, those kinds of things. But I think there are a bunch of things that are going to help people understand things, not necessarily replace people.
Donald, James, thoughts?
I mean, I kind of view, I hate the AI thing because when I look at machine learning, it's just algorithms that we've packaged in various things like Spark and you name it. They're not really AI. They allow you to look at a certain thing. Oh, I want the Gaussian path that's the least to do that. So, with testing, I've been thinking, what Rosalind said too, that I've been looking at historically. I watched people would build large databases with rows of things they should test. And I've been thinking, wow, maybe you could take that and drop that in some kind of framework like Spark to produce better tests, because then you could, put it in a data lake, or this is just the thought I've had. I haven't done it yet, but that's one of the ways I've looked at it so far. I'm not worried about AI replacing any people anytime soon. I don't think Arnold is coming to find me anytime soon.
Okay, James, wrap us up on AI. Ooh, is he still there? He may have, looks like his image is frozen. Okay, James may have lost his connection there. Hope he can get back. And thanks to panelists and thanks to the audience too, there's a really great conversation kind of running in the background here on the chat. So please join in that. Some interesting things. One of the questions I think it was Rajesh brought up was, AI and test data reduction. Just my own observation, and I did some early AI, basically meaning Prolog and Lisp work a long time ago. But AI often today is machine learning algorithms, and I think one of the reasons why it's risen in popularity, other than its misuse of the term, is that we have vast quantities of data, and what can that tell us? And there's sort of directed algorithms, and there's unsupervised and unsupervised algorithms. And that seems to be an area, I know in other domains, they're using that data to try to find new patterns. And is that valid for us to consider what we could get from all the tools that we use for testing? What might we learn from that data? Thoughts on that?
So I think, Mitch, that especially, and we haven't talked a bit about the continuous testing, but I think in today's reality, and we talked a bit about the complexity of software, the growing complexity of software, we are generating tons of data in the background. Some of it's test data, some of that it's production data, logs, whatever. There is simply no option without really smart, intelligent tools, and it can be automated, it can be machine learning or AI. That's not the conversation here. You need something efficient that can drive or guide you to a smart decision-making process in this ever-growing data volumes. So it comes from production, observability that can really analyze all this stuff. It can be just your pipeline, right? What's happening in your CI in Jenkins or Bamboo or whatever CI servers that you are using, okay? But you need something to really help you slice and dice all this data that comes from so many different areas and interfaces, so you can get better and smarter decisions for your next iteration, for your next software delivery, and for how you actually are going to serve your customers. So in my mind, that's one of the growing pains in today's reality, the boost of data, and you don't know what to do with it. So that's a huge problem to have.
Awesome. I see James is trying to reconnect. Hopefully he can connect back with us. So we're with you there, James. We're pulling for you. There's a really interesting question, I think, that I'd like to pursue that one of our audience members contributed. Essentially, it's what can we use the cloud for when it comes to testing? And let me give you an example. What sort of kind of clicked the light to me about cloud early on was I saw an Amazon presentation about how they did rolling updates of their software in production and could roll back if they needed to, if they found an error. There's something different. I hadn't thought, when you have that much capacity in terms of data and compute and network in testing, what can we do in the cloud because of the cloud that maybe was hard, difficult, maybe not even possible before?
Not to be controversial or anything, but I could do rolling updates on Z since when? I mean, what's new about that? Okay, sorry. I think when we think about the cloud, we have to think about the elasticity we have the options of using. And by the way, we've had them forever. We just don't always recognize that. I've been able to do a lot of this. The cloud makes it easier, and it makes more people realize this flexibility. But the spin up, spin down, the dynamic nature, being able to do more, to take advantage of things. I mean, rolling updates just are plain obvious.
Probably where they started there, right?
Yeah, I mean, you should have been doing this forever with a rolling update. You've been able to do it forever. It's just a logical thing to do. So doing that in the cloud makes a lot of sense. Doing things like getting more test environments, and maybe I'm not spinning up a full copy of production because, yeah, that sometimes can be a nightmare, but spinning up an environment to be able to do early testing, to do those kinds of things. Take advantage of A/B. It's much easier to do that kind of dynamic testing in the environment if I can spin up a section in part of the world. This part of the world's going to see this capability. Let's see what they want, etc. So there are lots of options when we take advantage of the elasticity of the cloud.
That's our welcome back, James. We're glad you made it. The
I'm on a
topic
different
is
computer now because of the fine tradition of quality that Microsoft and Google have set for us.
There's a
And right now,
cooperative
my
bunch.
system says working on features 91% complete. Do not turn off your
Oh,
computer.
nice.
After
Okay.
my system said I had to reboot. And anyway, I'm sorry about
Software
that.
updates and webinar
Our
roundtables don't go
frustrating
well
one, there's
together.
apologize to the global hive mind for insulting AI. Please let me speak.
Yep. Okay. So let's go back, let you comment on the AI topic. And then what we're discussing now, James, is what kind of what does the cloud enable us to do with testing we maybe couldn't have done without it? So before you go there, let's hear about your thoughts on AI to wrap us up.
Oh, I just wanted to suggest that a good way to think about AI is to think about it as a hunting dog that comes with you on the hunt. If you understand the capabilities of a hunting dog or a child. I mean, my 17-year-old son helped me test a medical device once, and he found a critical bug that caused a medical device to melt inside the human heart, which is probably bad, right? But the thing is it was his first time testing. I wasn't relying on him to write the test report. I wasn't relying on him to set the test strategy. I gave him a challenge and said, if you can find a bug like this, it would be fantastic. And geez, he found it. He used his video game skills to do something that nobody had thought of doing. And that led to a very serious condition. So I understand, I have in perspective what he was capable of doing, and I was able to accept his help. And this really says everyone can be a tester, Rosalind. I think that's part of the point you're making, is anyone can be a tester, but someone needs to take responsibility for testing. And to take responsibility for testing is a little different than saying I can find a bug. AI can help us find bugs in lots of ways if we allow it to help us. And I look forward to interesting tools that say, hey, James, maybe there's a problem here. I just detected something weird going on. Just everyone remember HAL 9000 detected something strange going on. It turned out he was trying to kill the crew. That's
not a good outcome.
Yeah. Go
Violates
watch the
one of
documentary
Asimov's rules for
2001 A
robots.
Space Odyssey about that.
Yeah. Violates one of Asimov's, I think, first rule about robots. So on the next question, maybe I think Rosalind was offering Iran or Donald or James who can jump in because of the cloud, the availability of it. What kinds of things related to quality, software quality or testing does that enable us to do? What are some new uses of the cloud for testing?
Well, to me, it kind of leads to the DevOps, GitOps concept, which is the ability to deliver more often and be able to run a pipeline that allows you to run your tests, see if it's good, drop it out there, do a canary, a blue-green release, roll back. You can do that a lot more. Amazon does updates 53,000 times a year to their cloud. Microsoft is pretty close to that. I can't remember the exact number. So the ability to do that is very valuable, but that really involves that you've sort of swallowed the whole GitOps, DevOps methodology, which is, if you haven't, that makes it really difficult because you can't you can't use all that scalability because you don't have all of that together to do it. I mean, that's really, to me, the next step. DevOps is there. And GitOps is really interesting where you start tying code to how you deploy all these things, whether it's infrastructure, applications, microservices. It's a valuable thing.
Just to complement Donald and add some context, you ask about what cloud can do for you that it couldn't do like in the past. I think that all these platform as a service that you get from the cloud, all these iPhones, all these desktop permutations that you are getting as a service without the need to go and buy them. I know that a few of my customers are relying on our cloud. The same day that a new iPhone comes out to the store, they want to be able to test on it. Okay, there wasn't any other way before the cloud. You needed to go to the store, to the Apple store, wait outside in line, and get this new iPhone 15 or iPhone whatever 20 that will come up later, just to test it the same day, just so to make sure that your app is still working. Today, you have the ability to really get these devices virtualized. Again, these are real devices, but from the cloud as a service, so you can get faster confidence in your software without, these lengthy delays that you used to have. So that's just one use case. Donald gave other great use cases. I think cloud serves you throughout the entire software development cycle. Deploying continuous deployment, right? There is a fantastic new company called Bitrise, right? They are doing continuous delivery and deployment as part of the cloud native service that they have for mobile apps. Okay, that's huge velocity, that's huge productivity for developers. And since it's connected to CI, that's their CI, you can actually do some testing as well prior to this deployment. So these are great use cases.
You notice we just had a pandemic, and the
was in all the papers.
software industry did not collapse. It thrived, and it was able to thrive because companies like Zoom, especially Zoom, were able to scale up amazingly, dramatically, way faster than they ever thought they would have to scale up. That's only possible in the kind of architectures that we see with the cloud. So in a way, the cloud saved our industry this past year and a half, and it made possible distributed work in a way that's never been possible before now. And we just had a stress test of that, and it really works.
Agreed.
I work with a company in Vienna. The worst thing that I have to deal with is I work all night and I sleep all day because I work with a company in Vienna. But as far as the fluidity of the work and the ability to get everything I need, and they to get everything they need from me, it's a wonderful system. It works really well because of the cloud.
Fortunately, we had cloud enough before the pandemic that we could also do things like set up our remote development environments or virtual development environments, as well as test and data being located somewhere other than our data center or on our desktops at work. So timing of this was really important, I think, James, to your point about why it helped us be successful. We knew how to do remote development already, or let's just say distributed development.
If this had happened 20 years ago, it would have been a major economic disaster for the technology industry, not just the restaurant industry.
Yeah, absolutely. Well, we're approaching the end of our time together here. I definitely want to thank all of you, and I'm so glad you made it back with us, James, and hopefully your updates will happen not during the next.
They seem to finish,
panel.
Yeah.
So, boy, we feel your pain on that one. Let me first just jump into letting folks know who our winners of the gift cards are. The winners are Kaylee V, Stacy H, Gordon M, and Yuri G. And the folks at DevOps.com, Media Ops, will be in contact with you to get those gift cards to you. You know, it was as expected and predicted, lively conversation, discussion, disagreement as well as agreement, and which is super valuable. I mean, I don't think folks tune in to hear 5 people say the same thing and agree about everything. So we certainly accomplished meeting that, and there's nobody to thank but our panelists here. And I also want to thank the audience. There's been this great rolling conversation, you know, people like William and Sujeth and can't think of everybody, Mahesh, Marcus, a whole bunch of people. I mean, a whole bunch of people were commenting, answering each other's questions. And no better use of the technology is help us to engage with each other. And I think that happened today. So thank you for your time, panelists, and your contributing your knowledge and your expertise and experiences. And we also want to thank everyone in the audience. You know, your time is very valuable. Spending an hour on anything and an hour with us, we're honored that you spent it with us. So we hope you have a good rest of your day. Thank you to all of you. Take care.
Thank you.
Thank you.